Okay, in this video we're going to talk about actually finding some epsilons given deltas with linear functions, quadratic functions, root functions, that sort of thing. Some of our more common functions. Um, so let's start out with a linear function. We'll just draw a picture first, and then we'll do things algebraically after we've got the picture. So we've got a linear function. Let's say that this thing has slope 3. Let's say that this is y equals 3x minus 12. Okay, so that's what this graph is, and we want to find the limit at, let's say, c equals 5. Okay, so we know on this graph that when c equals 5, this should be at 3, right? This should be at the point 5, 3. And so this limit should be 3 here. But what I want to do is I want to give you an epsilon, and then I want you to tell me what delta we will have to use so that when I'm delta close to 5, that the outputs are epsilon close to 3. So we're going to say let's let epsilon equal say, let's go 0.25. Maybe I want to be within a quarter of 3. Okay, that's not very close, but it's close enough to kind of see how this stuff's going to work. So let's zoom in on this picture a little bit. So if I am epsilon close to 3, that means I'm up to 3 plus epsilon, which is 3.25, and I'm at 3 minus epsilon, which is 2.75. And if I dot over and I dot over, I want to know what delta I will have to put down here so that if I go left delta and I go right delta, I am inside the box no matter which x I use for this delta. So the one that I drew was a little bit too big because this stuff here, it's in the delta width, but it's outside of the epsilon width, right? So I'm gonna have to bring this in just a little bit more. And there was some stuff here too, right, that was outside the box. So what I need to do is I need to bring that delta in a little bit more so that all of the points within this delta would be inside the box, right? Now all of these are inside the box, right? Here's the delta bit of the box, 2 delta wide, 2 epsilon tall. All of the points on the graph are within that little box, right? If I go narrower, it still works, right? If I make delta smaller, it still works, right? My tolerance was a quarter. If I've hit that tolerance and I require more from my inputs, I require them to be closer, the tolerance will still be hit. But I can't go much wider, because if I go wider, then some of this stuff will end up outside the box like we had to start with, right? This bit here at the top corner and this bit here at the bottom corner were outside when I first drew my deltas. So how do I find the right delta? Well, let's get rid of some of this stuff that we drew with our picture and start again. So here's this picture. Well, I know this point and this point are on these horizontal lines that we drew, which were the top of the box and the bottom of the box, right? So what I'm going to try and do, here's my point at c equals 5. Okay, so I'm going to try and figure out where the function crosses these epsilon boundaries, right? The top epsilon boundary and the bottom epsilon boundary. So I want to know what this point is. Well, to get an output of 2.75, I would need 2.75 equal to be 3x minus 12. So I add 12 to both sides, I get 14.75 equals 3x. Divide by 3, you get 4.91 something something, right? And so 913 repeated, I think. Okay. So I'm going to go down to the left-hand interval of this is 4.913 repeated. And I do the same thing with the right, and I think I get 5.086 repeated. These are 6s, and this is a 3. Trying to do arithmetic in my head. 6s there, 3s there. 0.25 divided by 3 is 0.0833333. Okay, it's 8 1/3. 25 divided by 3 is 8 1/3. So I want to go 8 1/3 to the right and 8 1/3 to the left, hundredths. And that gives me my 2 points here, right? I've solved this one. That's a 6 repeated. And I've also solved 3.25 equals 3x minus 12, and I get that x equals 5.083 repeated. Okay, so those give me where the box would be if I had corners here. Corners where the function hits the dotted lines, the horizontal dotted lines. Okay, and because this is a line, everything's balanced to the right and to the left. It's the same distance, right? Same distance up, slopes all the same. So I can choose delta equal to p 0.083 repeated. As long as I take an x value that's in here, so x minus 5 less than 0.083 means the distance from x to c is smaller than the distance from c to 5.03 to 5.083 or 4.916 repeated, right? So as long as x is within there, we get that L minus, we get 3 minus f of x is less than 0.25. Okay. Let's see another one of those. It's not a line, so we can see how this works just a little bit better. Let's just draw the picture and not do any of the algebra yet. So I'm going to take the square root function, and let's say here at 1, I've got this point 1, 1. And here's 1, and maybe I want my tolerance to be a quarter again. So I've got 5/4 up here and 3/4 down here. Okay, so this point here and this point here are the points where the horizontal lines cross. if we want this rectangle to be the one that we look at, so here's epsilon up, epsilon down, right? So it's a 2 epsilon tall box. Because this is curved, this side is a lot longer than this side. The center here at 1, I have to go a lot farther to the right than I do to the left. Or I can go farther to the right than I can go to the left. And so when we were finding these intervals centered on a point that were inside of an interval, that's what we're doing now, right? So the square root of 3/4, sorry, this is my input, so this is 9/16, yeah, and this is 25/16. So I have to go 7/16 this way, but I can go 9/16 this way, right? So the delta that I'm going to pick is going to be the shorter of the two. I'm only going to go centered 7/16 this way and 7/16 this way. That way, if we set delta equal to 7/16, then no matter if I go to the left or the right by at most 7/16, I will still be in this box that we drew, right? I've just kind of made the box a little bit smaller. So this is the box that we'll use as our sort of proof box. As long as I'm within this box horizontally, the function values will be within the box vertically. I could have gone a little bit further to the right, but I can't go that same distance to the left. And the way that the expression is set up, it's set up so that 0 is less than x minus c is less than delta. This delta has to be the same distance to the right and to the left. So we pick the smallest of the two so that this interval leaves us inside of a good box for this limit. So we're going to pick 7/16 as our delta in this situation. When epsilon is 1/4, we let delta equal 7/16. Okay, let's do another one algebraically. Let's look at, say f of x equals 1 over x, and we're going to be at the point at c equals, let's say 4, and then the limit would be 1/4, and we're going to say epsilon equals 0.01. I want to be within 1/100th here, and we're going to calculate what delta will have to be. So let's start by drawing a picture, just because they're helpful. So I've got my 1 over x curve, and then here at 4, 1/4, right, is where we're going to be focused. This is at 1/4. I'm going to go up just a little bit, and I'm going to go down just a little bit. The up just a little bit is 1/100th. So this is 0.26, right? A quarter is 0.25, so this is 0.26, and this is 0.24. And we try and find this point, and we're going to try and find this point. And these 2 points are going to give us the horizontal box that we get to work with. We're at 4. I want to see how far that way and how far that way I can go. I don't think I've got horizontal lines here. This, I think, should be farther to the right than it is to the left, but we'll just figure out what the numbers are, and then we'll go from there. So this is going to be at 0.26 comma 1 over 0.26, which is as a fraction 0.26 comma, well, that's 100 over 26. And this one is 0.24 comma 100 over 24. The reciprocal of 26 hundredths is 126ths, and the reciprocal of 24 100ths is 124ths, right? Okay. So if I want to take the shorter of these two distances, right, I've got 100 over 26 on the left, 100 over 25 is where 4 is, this is equal to 4, and I've got 100 over 24. I want to find the smaller of these distances, right? Is it this way or is it this way? So we're going to take the difference of these things and figure out what they are. So I've got 100 over 26 minus 100 over 25, and that's 25 minus 2600, so that's 100 over 25 times 26. That's 4 over 26. Similarly, 100 over 24 minus 100 over 25. This will be negative actually, but we're just worried about absolute values. Okay, this is going to be 100 over 24 times 25. So that is 4 over 24. So this is 2 over 13, and this is 2 over 12, because that'll be easier to compare. Which of these is smaller? This one is smaller because it's 2 divided into smaller pieces, 13 pieces instead of 12 pieces. So we're going to choose this to be our delta. That's going to be the smaller of these two distances. So if I choose the smaller of the two distances, that was the 26 one, that's this way. So this is delta and delta, and we're ending up in the box if I choose that delta. Okay. Let's do an actual full proof of showing something is a limit here. Let's prove that the limit as x gets close to 2 of x squared plus 1 is 5. Okay. So how this starts out is, well, I have to take a tolerance in the y direction and then show that given that tolerance I can find a delta that makes this all work out. So we're going to start out with a tolerance. We're going to start out with some arbitrary tolerance. We're going to let epsilon be bigger than 0. That's going to be our arbitrary tolerance. We're going to do some scratch work over here, and we're going to figure out what delta has to be given this epsilon. So let's draw this picture. I've got x squared plus 1. I'm over here at 2. So this is at the point 25. And I'm going to go up epsilon, and I'm going to go down epsilon. So this is at 5. This is 5 plus epsilon and 5 minus epsilon. And then I want to find what these boxes look like. Well, because we know what the x squared curve looks like, it's not as steep on the left, it is steeper on the right. Yeah? So which of these is going to be closer to 2? Well, it might be hard to tell. So let's solve for each of these. So I've got 5 plus epsilon equals x squared plus 1. So I get 4 plus epsilon equals x squared. Right? And so 4 plus epsilon, the square root of that is equal to x. And it'll be similar with a minus sign on this side. So this is at the square root of 4 plus epsilon. This is at the square root of 4 minus epsilon. Right? So we want delta be the minimum of the distance from 2 to this thing and 2 to that thing. So we're just going to say let delta equal the minimum of these two numbers. We're going to take, well, we want positive numbers in here, so we're going to take 2 minus the square root of 4 minus epsilon, and we're going to take the square root of 4 plus epsilon minus 2. Those are two positive numbers, and we want the smaller of the two. We see where we got those. We solved the expression so that we would be within the vertical bars as long as my horizontal bars were here. And then we took the minimum because I want to go the same distance to the left and to the right. Okay, then if x minus 2 is bigger than 0 and less than delta, we get that, well, x squared plus 1 is less than minus 5. In absolute value is less than epsilon. Okay, so let's just leave it at that. We'll write this 4-sentence proof. In a full proof, you might want to justify this statement, but we've already kind of justified it over here on our scratch work, right? We picked the right epsilon and delta pair for this proof. So your proof starts out, let epsilon be bigger than 0. We found this delta, so we set delta equal to this, and then we have our claim of the definition of the limit. Alright, I'm sure you will have lots of questions for me on Tuesday, but try and watch this a couple times. There's probably some other good videos out there if you want to try and find some of those too. And start working through the homework. See which questions, specific questions you have on the homework. Maybe don't ask me questions like, can you do number 3? But maybe you can say, okay, on this part of this question, I didn't understand this bit, right? If you can kind of focus in on where you're not understanding things, I'm going to be able to help you understand things better rather than just watching me do these problems. Okay, I will see you guys tomorrow.